So now that we've established the links between the numbers in Pascal's triangle, which are actually n choose r numbers, and the coefficients in binomial expansions, we can have a look at a general rule for all binomial expansions. If we say that we've got x plus y raised to the power of n, then we can come up with this rule to generate each of the terms. How many terms will there be? Well, if we've raised to the power of n, then there'll be n plus 1 terms. So here I've just imagined that n is at least, say, 3 or 4, so that I can generate at least 3 terms here so that you can see a pattern. And then we've got ... going all the way up to what would be the last term. Now, what you'll notice is that each coefficient is nice and sequential, starting with n choose 0, n choose 1, n choose 2, all the way up to n choose n. And then we'll have whatever the first term is raised to the same power as the power that our whole binomial expression is raised to, and then raised to one less, and so on until it's raised to the power of 0, which is 1. And that will mean that you won't have any of this term in that last term of your expansion. And then if we look at the powers of y, we start with y to the power of 0, which is of course 1, and that means there won't be any of this term in this part of our expansion. And then y to the power of 1, y to the power of 2, and so on, all the way up to y to the power of n. So really there's 3 things that we need to be mindful of when we're making our expansion. First, carefully consider the coefficient, and that will be this number here. Now you can generate those coefficients using Pascal's triangle if you've got it right in front of you, or if you're raising your binomial expression to a really large power, larger than what you have on your Pascal's triangle, or if you haven't got Pascal's triangle right with you at the time, you can use the n choose r button on your calculator to generate each of these numbers quite quickly and easily. Then you've got the other 2 parts of each term, the x part raised to a power and the y part raised to a power. Now don't be fooled into thinking that all binomial expansions are going to be as simple as this one. This one's only so simple because each of the terms in my binomial expression are just single pronumerals. So raising x and y to these powers looks very simple. But don't forget that each of these could be any term. In here we could have something like 2x plus 3y. You've still got the 3 parts to each term. This part is just a constant, and it's something you can generate with your calculator. But this part, if you've got, say, what did we say, 2x or something in here rather than just x, then you'll have 2x to the power of something. Now, when you raise 2x to the power of something, you're raising the 2 as well. So don't forget that these parts of each term can have constants in them, which then will need to be multiplied by that constant that's out the front. So my advice, just take your time, be really sequential, follow a procedure. Write out the terms using this method here, following this general rule, and then simplify the terms on the next line. That way you won't make a mistake and you won't have too much to do in each step.